So to play a sample, you need a sample player, and that's a different UGen that gets an audio file, puts it in memory, and then allows you to play it back. So here we have the lesson 4 base code, and we have a setup which basically says select input, and you select an audio file, and then it gets the path here, passes that to the sample manager object as a file name, which creates a player, and then it's just the same as before. Plug it in, player, add input to G, which is the gain, and add G to the output, and you've got a sound. So let's give that a whirl. So here we have setup, size 300, 300, AC equals new audio context, select an audio file. Let's hit it. So I'm going to go to desktop. I know there's a conga and a 1 hit there. And I get a sound because I've selected it. When I select it, it runs this code, file selected, and off we go. We go audio file name, get absolute path, set up the player, and play it out. Now I'm just going to make a few changes to make it a little bit more obvious what's going on. Here I'm just going to change the name of this to sound, and I'm going to call sound directly there. Sound, in sound I'm just going to specify the path, the entire path of the file. You could also do a relative path. And then I'm going to set up the player just as I did before and play it out, and it'll sound like this, which is very simple. So, what do stereo or mono samples mean? So samples come in either 1-channel or 2-channel files most of the time. There's also 4-channel and 16-channel as well. But most of the time there's either a 1-channel file, a mono sample, or a 2-channel file, which is a stereo sample, which has 1 channel for the left speaker and 1 channel for the right speaker, or 1 channel for the left headphone and 1 channel for the right headphone. Those individual channels are interleaved into a single list. So you'll have 1 sample for the left and 1 sample for the right in a long list. So you get 2 lists of audio data out of a 2-channel file. Using this in Beads is not very difficult. Basically, the one thing we need to change is in the gain, we need to set 2 channels rather than 1 channel. So we need to have 2 channels of gain, and we pass the 2-channel player into the gain. The player here instantiates with the right number of channels based on the file, so you just need to know how many files. You can also ask the player how many files it has. Then we hook it up in the same old way. So let's have a quick look at that. So firstly we'll look at the panner. This is a panner that takes a single audio channel and pans it across to 2 channels. And it takes a value for where it should be panned. So if it should be panned to the left, we have 0 here. And if it should be panned to the right, 1. And if it's in the middle, 0.5. That's based on applying gain to each of the channels here, these multipliers of the gain objects. So if it's 0.5, to work out the gain, we just pass 0.5 directly to the left channel, and then we do this little calculation. We multiply by -1, so we get minus 0.5, negative 0.5, and we add 1, so we get 0.5 again. So if it's 0.5, we're going to have gain of 0.5 and 0.5. But if it's set to 0, well, you get 0 here, so no left channel, and 0 times -1 is 0, plus 1 is 1. So this right-hand channel would get all the sound. And if it's 1, 1 times -1 is minus 1, plus 1 is 0. So this would be 0, and that would be 1. So that would be the channel that gets all the sound. So you can pan back and forth by changing this parameter here very quickly and move the sounds back and forth between the two speakers. So to look at the code directly, here we have our audio file name that we used before. This is a single channel file. Well, maybe we didn't use it before, but this is a single channel mono file. We load it up and we have a player there. Now here we have a panner and a gain with two channels. The panner is instantiated with an audio context and 0, which actually means the middle. The panner takes -1 to 1 as its values. That lines up a bit better with oscillators and things like that. But essentially it's doing the same thing as 0 to 1. So here we add the player to the panner as an input, and it is panned in the center. And then we add the panner as an input to the gain, and the gain goes into the output. So let's run that. So it's in the middle now. If I change this to 1, and -1, so there we go. Pretty easy. You can also, of course, have -0.65, and you get a bit of both, mainly over on the left. So using samples can be a bit confusing. There's lots of different types of sound that is recorded, so using them in different contexts can be a bit of an art. But if you have a few different categories and you understand what they're doing, that can make life a bit easier. So the first category is one hit. That's where you get a sound that starts and fades out. Now, the sound I played with the guitar tone, that's a one-hit guitar tone. It has a tone, but it doesn't repeat. It just plays and then fades out. You could have a one-hit type of thing with a crash or a banging a can or something like that. All of these things could be very short sounds that fade out quite quickly. The good thing about that is you know when they're going to start, and you know they're not going to restart later on. So if you play one, you can play a lot of them at particular times, and you know you're going to get sounds at those particular times that you play the sounds. You're not going to get repeats of the sounds or sounds that continue on. So that can be a good strategy for associating interaction with particular sound effects. The next thing is background noise. Now, background noise is really important for giving a sense of place, giving a sense of environment. So here we have an atmosphere sound with small creek birds and crickets. They're usually a bit longer than the one-hit sounds. You see this is so short it's not even 1 second, but this is 47 seconds. And that's pretty common. So this will be a long file that has a lot of little quiet sounds in the background, and that gives a sense of place to the piece. So you could have background noise, or you could have background music, or you can have both. Sometimes both is appropriate. Now, another type of sound is a rhythmic or chordal sound. So you can have a rhythmic sound, or you can have music playing that involves chords, or both. Now, the problem with these is that rhythmic sound kind of takes over, and it requires everything else to be in time with the rhythm. So if you have one sound and you play one-hit sounds at the wrong time, it sounds a bit weird. So rhythmic sounds, they're a bit harder to use. They're a bit harder to use properly. Be careful. Chordal sounds are even more complicated. So if you've got a rhythmic sound that's just hitting a drum or something like that, that doesn't affect the tone, but if it's playing a chord on a keyboard or something like that, then not only do you have to be in time, but you also have to be in the right key as well for it to sound sensible. So that makes getting the right samples difficult. So you need to have a whole kind of process for that. Probably a bit of composition training as well. So if you need to use rhythmic sounds or looping rhythmic sounds, that's fine. But just realize that they can be a little bit more tricky to use than others. So here's an example of a rhythmic sound. You can see a regular beat coming out here. Here's another regular beat. This end bit here needs to be chopped off so you can use that whole regular thing as a loop. Here we have some chordal sound. A Rhodes is an electric piano, so that will be quite a chordal sound. These samples have all been taken from Freesound, and you can download free sounds from freesound.org. Another thing is a pad. That's kind of like a chordal sound, but a long tone that doesn't change. So it's like a sine tone, but instead it's like playing multiple notes. They can be quite good for giving a bit of an impression of musical sound. You fade them in and fade them out, and it's not very difficult to use these to give an impression of music. And the last one is speech. So speech can be really great if you want to kind of signify something, but you have to make sure you understand the speech and it's easy to understand. It's not too fast, it's not mumbled, and it's pretty easy to stand. Now, the next thing is sample playback rate. So the sample playback rate determines proportionally its pitch and duration relative to the normal sample rate. So this is basically the same as an image. If this is the normal sample length, then if we speed up the sample play rate and make it shorter, then we have to get through the same number of samples in half the time or something like that. That means the waves become half the length and they go up an octave. If we double the length, the waves become twice the length and we go down in an octave. So sample playback rate determines the pitch and duration. So I'll show you that here with this sample player. Okay, so here we have an envelope I've set up called rate, and I've set that automatically to 0.5. Then I've said player.setRate before I've passed it into the panner. And so that's been set at 0.5. Now if I set that to 2.0, we'll get a higher note. If I set it to 1, I'll get the same note. I can also set it to 0.1 to get a really low tone. Really low and long. Yeah. Now I can also add segments to that. So I can say rate.add segment 4.0 over 1 second. So I can start at 0.1 and go up to 4.0. Other way around. So that starts at 0.1 and goes up to 4 for the rate. So I can also start at 0.7 and go up to 1.5. Okay, so we can change the rate on the fly. So some samples, like sound or rhythmic samples, so with some samples, like background sound or rhythmic samples, you can loop them to create longer sounds. Looping just means replaying the sound exactly after it finishes. So you play through the sound, this is that background noise sample you saw before, and then you restart the same sample and you do it again. Rhythmic samples need to be edited exactly, otherwise the looping doesn't work. You need to get the rhythm correct. You need, if you want a 1 bar loop, you need to make sure that you have exactly the right amount of sample for 1 bar. So here's an example of me looping that sound that you saw before. So basically this is an A harmonic 1-hit guitar tone, and we could loop that, and it's very simple to understand what's going on there. We have the rate set to 1 now. We have set that rate there. Don't actually need to use either of those really. And I'm not adding that segment, so we'll leave that. Now I've said player.setLoopType, and I've set it to sampleplayer.looptype.loopforwards. There's loop forwards, there's loop reverse, and there's loop alternating as well. But loop forwards is the one you'll use most of the time. Then we've set the pan and the gain, and we've plugged the player into the panner, and the panner into the gain, and the gain into the output. Let's have a listen. Now this tone is quite long, so it will take quite a while before it re-triggers. We can fix that by changing the rate, of course, and getting through it faster. But once it gets right to the end, it will re-trigger. So if you want to hear it faster, we can set the rate to, let's say, 8. Okay. So for various samples, especially for the 1-hit type of samples, sounds can be repetitive if they are replayed. Sample groups, folders of sounds which all sound nearly but not identically the same, can solve this through allowing random selection. So you have a list of lots of different sounds that are basically the same. So they might be the same plucks of the guitar that we just heard, but they're not identical. They're different recordings, so they sound similar but not the same. And because they sound similar but not the same, they give a certain variation that can be quite nice, quite realistic. What you need to do there is you give the folder to the sample player, the sample manager, and say select from group, and then you give a number for the file in the group. So if the folder has 10 files, you can give numbers from 1 to 10. You can also randomly select a number from 1 to 10, and then you can have a random number each time you create a sample player. We won't look at that right now, but we will look at it later. Now, another effect that's really interesting is a delay. A delay is a simple effect made by storing the sound and replaying it in a short time like an echo. It requires a delay buffer, a record head, and a play head. And sometimes there's also a feedback loop. So this is an example here. We have an input. It goes straight to the output as well, but it goes into a buffer where it's held for a period of time. Now, how long it's held for is up to you, but it could be held for a 1/10 of a second, or half a second, or a second. And however long you want to hold it for, you need that much memory for the sound, and then we basically constantly fill that buffer with new sound, and then we can read from the sound from that buffer at whatever point we want to. So we can read at 1 second, or half a second, or 1/10 of a second. We just have to set the playhead at the appropriate point. Once we pass that to the output, we're going to get an echo. So if we record the sound, hold it for a second, and then play it out, we're going to get an echo at 1 second. And 1 echo is fine. but you might want multiple echoes. You might want a sound to have a kind of an echo that continues on. And in that case, you need a feedback loop. So here we take the delayed sound, we multiply it by a gain value, so usually we want to turn it down a bit, so 0.5 or 0.2. So we're turning down the sound that we pass back into the buffer so that we don't get a feedback loop that blows up. Because if we have the same sound or a greater sound, we're going to end up with the buffer being full of sound that is amplified and then re-amplifying that same sound. So we want to avoid that, so we make sure that we multiply by a lower value. Then that goes back into the buffer and it's fed back over and over again, and we get an infinite loop. That can be quite fun. Similarly, reverberation is the simulation of the effect of a sound bouncing around a room. So in a room, if you play a sound in that room, you're going to get a direct sound at the listener point. So this is the source and this is the listener, and the direct sound is the direct path to the listener. And it's always the shortest path. It's as the crow flies, so to speak. Then you're going to get the first few reflections, and they're going to be the big strong reflections of the sound bouncing off the wall and hitting the listener. Some of them will be one wall, some will be two walls, and some might be 5 or 6 walls as it goes around the room. Those early reflections are quite strong, and as they hit more and more walls, they get less strong. They're going further, the sound is dropping away bit by bit, and it's becoming more chaotic. So we start with the direct sound very clear, then a few clear, simple reflections, and then a bunch of chaos as more and more reflections that are lower in value go in lots of different directions. This all depends on the acoustics of the room, of course, but reverberation is an effect that is quite commonly used. Okay, let's take a look at that. So here I have the same example with the guitar sound set fast so we hear it fairly quickly, and we've got 3 new objects here. We have a tap in, T in, which is a new tap in, and that's the buffer. It's 1,000 milliseconds long, and we have AC to set it up. So that's the input to the buffer. Tap out is a new tap out, and it takes the tap in as an argument because it needs to know which buffer to look at to use its playhead. And then we set the delay time within that buffer, 500. If we make it greater than that buffer length, we'll have problems. And then we plug in the player to the tap in, and that becomes the record head into that buffer. And then we have to plug the output of the tap out into the panner. So we're connecting everything up as you'd expect. So now we get a little delay, half a second. We can also apply gain to that, and we can also feed that back in to the tap in. So let's have a go at that. We'll get our gain. I'll call it G delay because it's a gain for the delay, and we're going to use 1 there, and we're going to say G delay dot add input T out. So that's going to plug the gain in to that, and we're applying gain of 0.5. And then we're going to plug that gain back into the input. So we're going to say tn.add input G delay. So now we've got a gain that is going to link the output of the delay back into the input. So you can now hear the infinite loop that we talked about. And we can do it faster as well by changing the tap out time. And we can also switch this back to long version, and you hear the change in the time there. So that's a way of creating a longer delay. We can make the delay hang around for a bit longer by changing this to 0.9. Okay. So finally, musical notes are drawn from a scale, and the scale is a selection of notes from a 12-note space. You've already had a look at a lot of the notes in the scale with MIDI note numbers, but basically here is that example again. So here's a keyboard, here's the staff of a musical scale, and here are the MIDI note numbers. They're very small, but you can still see them, and the frequencies of each of those numbers. So in the low keys we've got 130, around the middle we've got 260, up at A 440, and then all the way up to the top is about 1000 Hertz. And that ranges from 84 down to 43 or thereabouts. So these are the notes that fit on the musical staff. A scale is, the most simple scale is the white notes of the keyboard. And we can see some notes are left out. These a selection of the 12 notes, and you can see C and C is the octave. So basically, if we look at this, we can say that's C, D, E, F, G, A, B, C. That's 8 notes out of 12 possible choices of notes. So that's a scale. The other possible scale is the minor scale, which starts in A and goes up to A for the white notes, but we have a few options there. So you might be wondering, why is C and C and C all related to each other? Why are they all called C? Well, that's because of the harmonic series. The harmonic series describes the relationship between waves. And if we look at this red wave here, we see a nice simple wave, but do you notice they all pass through the same point here? And they all join up here as well. So if we multiply the wavelength by 2, we get the blue one here, which instead of having one cycle of this wave, one up, down, and back to the center, it has 2. We go up, down, to the center, up, down to the center. And that's the octave. So if you multiply a wave frequency by 2, you get the octave. And you'll see that's the same if you look at the numbers here. So if we look at 260 for C4, and we go up to C5, we're at 523. So that's doubling that frequency. So scales and harmonies are based on waveforms and mathematics. Alright, so hopefully you now can play samples and control their rate, can apply effects like delay and possibly compression, can use frequency modulation synthesis, can use low frequency oscillators, and use chords and harmony, the harmonic series especially. So as we work through these things, you'll find the combination of each of these ideas gives you a lot of capabilities for complex and interesting interactive experiences. So learning about music and harmony alongside drawing and interaction really gives you the capabilities for a really engaging interactive experience. Thanks very much.